This module will cover the Level 3 inputs and implementation of jointed plane concrete pavement in AASHTO-AIR pavement ME design. This is the fourth module in the Level 3 input series for MEPDG inputs and implementation. As before, the G.User Input Guide and Train the Trainer workshop manuals are considered necessary tools for this module. We will continue with the pavement structure process, focusing on the PCC layers of a JPCP design as shown in the highlighted figure. First, a brief overview of the rigid pavement design structure. Rigid pavement designs are limited to one PCC layer for new pavements and two PCC layers for rehabilitation designs. Typically, only one of the following base layer types are used for rigid pavements, and no more than one stabilized subgrade base layer should be used. The subgrade for rigid pavement designs is limited to two layers, compacted embankment and natural or undisturbed soil. If you are unfamiliar with the input processes for the subgrade or base layers, please review Module 2 of this series. Next, we will discuss the design property inputs. Navigate to the Explorer window and select JPCP Design Properties in the Project dropdown. Unlike the flexible pavement design properties, some JPCP properties may differ based on your project specifications. The first design input is surface shortwave absorptivity, in which the default value of 0.85 should be used for all new and rehabilitation designs. Under the dowel joints dropdown, you'll find the inputs for the dowel diameter and dowel spacing. The dowel diameter table in the User Input Guide provides recommended diameters based on slab thickness, while a dowel spacing of 12 inches is suggested for most designs. The erodibility index for JPCP is defined by the type of base material for the project and is classified by categories presented in the highlighted table of the User Input Guide. Under the PCC base contact friction dropdown, JPCP design should always use full friction between the slab and base course, while the months until friction loss is based on the type of base course used in the design. Reference the appropriate section of the User Input Guide for the suggested input. Under the Joint Spacing dropdown, Pavement ME allows for two spacing options, constant and random. GDOT only permits the use of constant joint spacing with recommended values between 15 and 20 feet. For most JPCP designs, 15 feet is recommended. The permanent curl/warp effective temperature difference input should be left as the default value of -10 degrees for all new and rehabilitation designs. The sealant type input permits two available options for the transverse joint sealant, performed and other. Georgia currently seals joints with a silicone sealant, so selecting the other option is recommended. Both the tied shoulders and widened slab inputs are design-based and may change depending on the project. If the shoulders are to be tied, a longitudinal joint load transfer efficiency of 40% is recommended per the User Input Guide. Widened slabs are generally only used when reducing edge stresses from wheel loads is necessary. If this is the case, a maximum of 1 foot widening is to be used. After adjusting all design properties, you may begin defining the Level 3 JPCP layer inputs. Navigate back to the Materials window by selecting the JPCP layer at the top of the figure. The first layer property input is the Poisson's ratio. This input should not be changed as all relevant calibration factors are tied to the default Poisson's ratio value of 0.2. To determine the thickness of the concrete layer, first input a trial thickness using recommended values from the minimum and maximum layer thicknesses table in the User Input Guide. Then adjust the value in subsequent designs based on the performance output. Unit weight inputs should be selected based on average values from construction records if a particular PCC mixture is to be used. Otherwise, use a default value of 150 pounds per cubic feet. For Level 3 designs, the PCC coefficient of thermal expansion input is recommended based on the concrete's coarse geological class. Designers must determine the coarse aggregate type, then use the highlighted table to select the appropriate input from the User Input Guide. If the coarse aggregate is unknown, use a CTE value of 5.1. The PCC heat capacity and thermal conductivity inputs are tied to the GDOT calibration factors and should remain as the default values. Under mixed design properties, the aggregate type may be determined from the mixture design sheets or by locating your project location in the highlighted figure of the user input guide. Inputs for cement content and water cement ratio should be available from historical construction records, but if data is unavailable, use the recommended values of 660 and 0.45 respectively. For most Level 3 designs, the cement type input should remain as Type 1 unless otherwise specified. Under the curing method dropdown, the choices include wet curing and curing compound. Curing compound is recommended for most GDOT PCC designs, and wet curing is only to be used if the project specifically documents its use. The reversible shrinkage and time to develop 50% of ultimate strength inputs are tied to calibration factors and should be left as default values. The PCC zero stress temperature input is calculated as a function of monthly ambient temperatures and cement content. This value may be input directly by the user, but calculation is preferred for most designs. The same is true for the ultimate shrinkage input, in which the value is calculated internally. For Level 3 designs, the strength property inputs for PCC layers are limited to the 28-day compressive strength, or modulus of rupture, and the elastic modulus. The median values from GDOT historical construction records are suggested. These values are 6,097 psi for compressive strength, 705 psi for MOR, and 4,500 ksi for elastic modulus. All input properties have now been discussed for a JPCP surface layer. This concludes the content discussed in this module and the steps required to develop a Level 3 JPCP design. Proceed to the next module to learn about Level 3 MEPDG inputs and implementation for CRCP.